Good morning, class. Today we're going to talk about mole conversions for compounds. If we know the molar mass of a compound, we can use that as a conversion factor to figure out how many grams, moles, or molecules there are of that compound. Let's first talk about how we can convert grams of a compound to moles of a compound. An example problem might read as follows. Convert 25.0 grams of potassium permanganate to moles. The first step is always to calculate the molar mass. So if we have potassium permanganate, let's figure out our molar mass. We have one potassium that has a molar mass of 39.1 grams. And again, we find these values from the periodic table. We have one manganese that has a mass of 54.9 grams. And we have 4 oxygens that each have a mass of 16.0 grams to give us a total of 64 grams for oxygen. To find the total molar mass for the compound, we need to add 39.1 plus 54.9 plus 64.0 to give us a molar mass for potassium permanganate of 158.0 grams per mole. When we're converting from grams to mole of a substance, Step 2 involves dividing the grams present by the molar mass. This is so that the initial grams that we start with will cancel out and we're only left with moles. So we set up our conversion as follows. We're told that we're starting with 25 grams, so that value needs to go into the top left. Now, since we need to have grams on the bottom, we know that there's 158 grams per 1 mole. So that 158 grams needs to go on the bottom of the conversion so that our units can cancel. So notice that grams divided by grams cancels out. So to figure out how many moles this is equal to, we need to take 25.0 from the top and divide by 158.0 on the bottom, and that's going to equal a value of 0.158 moles. I'll give you a second to finish copying on this slide. Let's move on to our next problem. In this problem, we want to convert 17.0 grams of hydrogen peroxide, H2O2, to moles. So step 1 is always the same. We want to calculate the molar mass of our compound, hydrogen peroxide, and use that as a conversion factor. We have 2 hydrogens that each have a molar mass of 1.01, so the total molar mass for hydrogen here is 2.02 grams. We have 2 oxygens that each have a mass of 16.0 to give us 32.0 grams. So when we add 2.02 to 32.0, this gives us the molar mass of hydrogen peroxide, which is 34.02 grams per mole. Next, we're going to divide the grams present by the molar mass. So let's set up our conversion. We know that we're starting with 17 grams. So that needs to go in the top left of the conversion. Now, since we have grams in the top of the conversion, we need to also have grams in the bottom of the conversion. So if there's 34.02 grams in 1 mole, then we need to put the 34.02 grams on the bottom. That means the 1 mole goes on top. Again, notice that our like units cancel, and the only units that we have left are the ones that the problem is asking for, moles. So when we divide 17.0 by 34.02, we're going to get a molar value of 0.50 moles. And I'll give you a few moments to finish copying down the information from this slide. Okay, let's go ahead and move on to our next problem. We want to convert 75.57 grams of potassium bromide, KBr, to moles. Step 1 is, again, always calculating molar mass. We have one potassium that has a mass of 39.1 grams, and we have one bromine which has a mass of 79.9 grams. Adding those two values together gives us a molar mass of 119.0 grams per mole. Step 2, we're going to divide the grams present by potassium bromide's molar mass. So, setting up our conversion, we initially start with 75.57 grams. Again, since grams are the unit in the top of the conversion, we need to have grams in the bottom of the conversion. So that 119.0 needs to go onto the bottom. That means the 1 mole goes in the top. So grams divided by grams cancels out, and the units that we're left with are moles. Dividing 75.57 by 119 tells us that 75.57 grams of potassium bromide is equal to 0.635 moles. And I'll give you a few moments to finish copying down the information from this slide. Now, let's do a learning check question. I want you to convert 100.0 grams of potassium perchlorate, KClO4, to moles. I'm going to give you 3 minutes to do this problem. Please take another minute to finish working on this problem, and then we'll discuss the answer. Okay, now that you've had time to attempt the problem, let's go ahead and work out the answer here. Step 1 again is always to calculate the molar mass. So we have one potassium that has a mass of 39.1 grams. We have one chlorine that has a mass of 35.5. Notice that just to keep it with one significant figure after the decimal point, because that's generally enough. I rounded chlorine from 35.45 to 35.5. Then we have 4 oxygens that each have a mass of 16.0. making oxygen's total mass here 64 grams. When we add these values together, we should get a molar mass of approximately 138.6 grams per mole. Step 2 is to divide the grams present by the molar mass. Again, our initial value that we start with, 100 grams, needs to go on the top of the conversion, and then our molar mass, 138.6, needs to go on the bottom, because we start with grams, so we need grams on the bottom. That gives us the amount in 1 mole. So when we cancel out our like units, dividing 100 by 138.6 tells us that 100 grams of potassium perchlorate is equal to 0.72 moles of potassium perchlorate. And please take a few moments if you're still copying information from this slide. Let's go ahead and do another learning check problem. Now I'd like for you to convert 8.76 grams of sodium hydroxide to moles. You have 3 minutes to complete this problem. Okay, please take another few seconds to finish up on this problem, and then we're going to discuss it. Alright, let's go ahead and start discussing the problem. Step 1 again is always calculating the molar mass. We have one sodium that has a mass of 23.0 grams, one oxygen that has a mass of 16.0 grams, and one hydrogen that has a mass of 1.0 grams. Adding these three values together gives us a molar mass of approximately 40.0 grams per mole for sodium hydroxide. Step 2, we want to divide the grams present by the molar mass. Setting up our conversion, the value that we're told to convert is 8.76 grams, so that's going to go in the top. Now, if I have grams in the top, remember we need to have grams in the bottom. So the correct conversion factor would be to put the 40.0 grams in the bottom and the 1 mole on top, so that our like units will cancel out. Dividing 8.76 by 40.0 grams is going to give us a value of approximately 0.22 moles. So 8.76 grams of sodium hydroxide is equal to that value. And I'll give you a few seconds to finish copying any information on this slide. Okay, so we've talked about converting grams to moles, but what about if we want to convert moles to grams? Well, you're going to find it's not much different. Instead of dividing, we're going to multiply by the molar mass. Let's take this problem here. We want to convert 2.50 moles of potassium chlorate, KClO3, to grams. Step 1 is still the same. We need to first know the molar mass before we have our conversion factor. So, based on the formula, we have one potassium that has a mass of 39.0 grams, one chlorine that has a rounded mass of 35.5 grams, and three oxygens that have a mass of 16.0, which gives us a total mass of 48.0 grams for oxygen. Adding those three masses together gives us a total molar mass of potassium chlorate, of 122.5 grams per mole. Now, when we're converting from moles to grams, we're actually going to multiply the amount that we're given by the molar mass, and we'll see why that is now. Setting up our conversion, we know that the initial value always needs to go on top. So, if we're asked to convert 2.50 moles, we need to put 2.50 moles on top of the conversion. Now, here's the difference between moles to grams compared to grams to moles. If I have 2.50 moles to start with, then I need to have moles on the bottom here. If my conversion factor is 122.5 grams per mole, then the mole value that needs to go on the bottom is 1 mole, and the 122.5 grams needs to go on top. Let's just say 122.5. So when we multiply 2.5 times 122.5, again, this is a typo, we notice that the moles cancel out, and all we're left with here is grams. So what this tells us is that 2.50 moles of potassium chlorate is equal to 306.25 grams. The process for figuring out how many grams there are in a given quantity of moles is essentially the same. It's just that when you're setting up your conversion, you have to keep in mind that your initial value in terms of the units has to be the same as the units on the bottom here. So instead of dividing by the molar mass, we're multiplying by the molar mass. And I'll go ahead and give you several seconds to finish copying information from this slide. Let's look at our next problem. We want to convert 0.200 moles of hydrogen sulfide, H2S, to grams. Step 1, this might seem like it's getting redundant, but if we have our process and procedure in mind to do this, then this is exactly the best way to do it. Calculate the molar mass. We have two hydrogens that each bear a mass of 1.0 to give us a total of 2 grams of hydrogen. Then we have one sulfur which has a mass rounded to 32.1 grams. Adding these two values together, the compound H2S has a molar mass of 34.1 grams per 1 mole. Now, we need to multiply the moles present by the molar mass. So, setting up our conversion, our initial value of 0.200 moles needs to go on top. Notice that the units here are moles. So if I have moles on top here, I have to have moles on the bottom here. This is our conversion factor, 34.1 grams per 1 mole. So if I need moles on the bottom, I need to write 1 mole on the bottom, and we know that 1 mole of this compound is equal to 34.1 grams. Now we can cancel out our like units. When we multiply 0.200 by 34.1, we're we're going to get a value of approximately 6.82 grams. This means that 0.200 moles of H2S is equal to 6.82 grams. Please take a few moments to complete copying information from this slide. Let's look at another problem. In this problem, we want to convert 0.100 moles of potassium iodide to grams. As you can guess, step 1 is calculating the molar mass of the compound. We have one potassium that has a mass of 39.0 grams, and we have one iodine which has a mass of 126.9 grams. Adding these two values together gives us a molar mass of 165.9 grams per mole of potassium iodide. So let's go ahead and convert our 0.100 moles of Ki to grams. We're going to multiply the moles present by the molar mass of Ki. Setting up our conversion, we know that this initial value of 0.100 moles needs to go on the top. Now, we have moles as our starting unit, so the the units of moles need to be on the bottom here. Using our conversion factor, we know that 1 mole is equal to 165.9 grams. This allows us to cancel out our like units, moles divided by moles. So, if we multiply 0.100 times 165.9, that tells us that 16.6 grams of potassium iodide is equal to 0.100 moles of potassium iodide. And please take a few moments to finish copying information from this slide. As you're finishing up, we're going to do one more problem together, and then I'm going to have you guys do 2 learning check problems, and then we'll discuss those. In this problem, we want to convert 0.75 moles of sodium hydroxide, NaOH, to grams. Step 1, calculate the molar mass. I have one sodium that has a mass of 23 grams, and I have one oxygen that has a mass of 16 grams, and finally one hydrogen with a mass of 1 gram. Adding those 3 values together, we know that the molar mass of sodium hydroxide is approximately 40.0 grams per 1 mole. Step 2, we're going to multiply the moles present by the molar mass. So, setting up our conversion, the initial value always goes on top, 0.75 moles. Now, if we have moles here, then we need to have moles down here. We know from our conversion factor that there is 1 mole in 40.0 grams of sodium hydroxide. Let's cancel our like units. Now, from our setup here, we're going to multiply 0.75 times 40. Doing so gives us a value of 30.0 grams. So what this tells us is that 30.0 grams of sodium hydroxide is equivalent to 0.75 moles of sodium hydroxide. Please take a few moments to finish copying the information down from this slide. Now it's time for you guys to perform some learning check problems. Please take 3 minutes to convert 3.40 times 10 to the minus 5 moles of sodium carbonate, Na2CO3, to grams of sodium carbonate. Please take another minute to finish completing this problem. All right, let's go ahead and discuss the answer to this problem. The first thing we always do is calculate our molar mass. So, sodium carbonate has 2 sodiums that each bear a mass of 23 grams, giving us 46 grams of sodium. We have 1 carbon with a mass of 12.0 grams, and 3 oxygens that each bear a mass of 16 grams, totaling out to 48 grams. Adding these 3 values together gives us a molar mass of 106.0 grams per 1 mole. Now, since we're converting from moles to grams, we're going to multiply the moles present by the molar mass. So let's go ahead and input our initial value of 3.4 times 10 to the minus 5 moles. Again, what you should be noticing here is that whatever unit we start with on top has to be the unit on the bottom. So if there are 106.0 grams in 1 mole, I could also say that 1 mole of sodium carbonate is equal or equivalent to 106 grams of sodium carbonate. Now, when we cancel our like units, we can multiply the values on top. 3.4 times 10 to the negative 5th times 106 tells us that the value of 3.6 times 10 to the negative 3 grams is equivalent to 3.40 times 10 to the negative 5th moles of sodium carbonate. And please take a few moments to finish copying any relevant information from this slide. Okay, it's time for another learning check question. Please take 3 minutes to complete the following problem. What is the mass in grams of 4 moles of iodine, I2? Please take another minute to finish this problem. Alright, as you're finishing up, let's go ahead and discuss this problem. So, just like our other problems, we need to initially calculate our molar mass. We know that we have two iodines that each have a mass of 127.0. So, the iodine diatomic molecule has a molar mass of 254 grams per mole. Now, we need to multiply the moles present by the molar mass. Let's set up our conversion. So we're told that we have 4 moles of iodine. Since we have moles on top, we need to have moles on bottom. We know that there's 1 mole of iodine equaling to 254 grams. Cancel out your like units, multiply 4 by 254, and that tells you that 4 moles of iodine is equivalent to 1,016 grams of iodine. Okay, please take a few moments to finish copying information from this slide. Now, the final part of today's lesson is how can we put all of this together and convert from grams all the way to molecules. So we've only looked at conversions that involve one step, converting grams to moles or converting moles to grams. We need to be able to convert from grams to molecules and know how to perform two-step problems because this is going to be very useful when we start discussing stoichiometry next week. In general, we can use the following schematic to help us out. Notice that moles is the central value here in a conversion problem. So if we want to convert from the mass in grams of something to the number of atoms or molecules, we first have to figure out how many moles there are of that substance. In the reverse order, if we know how many atoms or molecules there are of a substance, to figure out how many grams there are, we need to figure out how many moles there are first. So as a general rule, whatever value you start with, you have to first convert to moles before you can convert to either grams or atoms. And again, you can use Avogadro's number to convert to atoms or molecules. Those are equivalent terms in this case. So, to go from mass to moles, or from moles to mass, we need to use the molar mass of the element on the periodic table. If it's a compound, then we need to use the molar mass of the compound. To go from moles to number of atoms, or from number of atoms to moles, then we need to use Avogadro's number. Please keep in mind that 1 mole is equal to 6.022 times 10 to the 23. If you're talking about an element, then you would say atoms. If you're talking about a compound, then you'd say molecules. So remember, this number never changes, and there's 6.022 times 10 to the 23rd molecules or atoms in any substance, regardless of its molar mass. Okay, so please take a few moments to finish copying down information on this slide before we tackle our first problem. Okay, let's look at our first multi-step conversion. How many grams are there in 35,000 molecules of sodium hydroxide, NaOH? Well, regardless of whether this is a one-step problem or a two-step problem, as you can guess, step 1 is to calculate the molar mass. We need to know the molar mass because that's our essential or primary conversion. So in sodium hydroxide, we have 1 sodium that bears a mass of 23 grams, and oxygen has a mass of 16 grams. Adding those together with the 1 gram from hydrogen, sodium hydroxide bears a molar mass of 40.0 grams per mole. Step 2, we have to formulate our plan. So here's how our plan is going to work. We're told that we have 35,000 molecules of sodium hydroxide, but we want to know how many grams there are. Unfortunately, we can't do that in one step because we can't convert from molecules to grams. However, if we know how many molecules there are of something, we can figure out how many moles there are of that substance using Avogadro's number, and then if we know how many moles that this molecule value is equal to, we can use the molar mass of sodium hydroxide to figure out how many grams there are. So let's look at how this problem would be set up. Notice that I have this conversion with 2 steps here. Okay, so again, just like any other problem, your initial value needs to go into the top left. So we're starting with 35,000 molecules. 35,000 molecules needs to go in the top left. Now, here's where we need to be very careful and always make sure that our units are canceling out. If I'm starting with molecules on the top here, then in this next box on the bottom, I need to have molecules as a unit. So, our plan tells us we're converting from molecules to moles. We need the value of molecules that are equal to 1 mole. So in the bottom here, we're going to input Avogadro's number, 6.022 times 10 to the 23rd molecules, and we know that's equal to 1 mole. Okay, so then our molecules will cancel out. At this point, we're now in the units of the mole. So we can use the molar mass of sodium hydroxide to figure out how many grams we have. If I have moles on top here, then on the bottom here in the conversion, I also need to have moles. So I know that 1 mole of sodium hydroxide is equivalent to 40.0 grams of sodium hydroxide. This is our molar mass. We need to cancel out our units to make sure that the only units we're left are the ones the problem is asking for, grams. Molecules divided by molecules cancels, moles divided by moles cancels, and please note that the only value we're left with here unit-wise is grams. So to solve this problem, we need to multiply through the top, 35,000 times 40, and then we need to divide by what's left on the bottom, 6.022 times 10 to the 23rd. When we perform these operations, we get a value of approximately 2.32 times 10 to the negative 18 grams. This means that 35,000 molecules of sodium hydroxide is equivalent to 2.32 times 10 to the negative 18 grams of sodium hydroxide. Okay, please go ahead and take a few moments to finish copying down the information from this slide. All right, let's go to our next example problem. How many molecules are there in 14 grams of BH3? BH3 is called borane. Step 1, calculate the molar mass. I have one boron that bears a mass of 10.8 grams, and I have 3 hydrogens that each bear a mass of 1.0 to give me 3 grams. Adding these values together, we have 13.8 grams per mole as our molar mass for borane. Now, let's formulate our plan. We're told that we have grams of borane here. So this plan is actually a little bit incorrect. So let me kind of discuss what's wrong here. What we should actually be looking at here, let me cross this out, is to go from grams to moles, and then finally to molecules. Okay, sorry, my handwriting's messy here because I don't have my pen tablet connected. All right, so this is why this is our plan. We have grams, we need to go to molecules. We can't convert directly to molecules because there's no conversion for that. But we can convert to moles first using the molar mass, and then we can use Avogadro's number to convert to molecules. Let's set up our conversion. Our initial value is 14 grams, so that's going to go in the top here. Then we know that whatever unit is on top here needs to be on the bottom here. So if we're converting first to moles, we need to use the molar mass. According to the molar mass, there are 13.8 grams in 1 mole of borane. Now, we're going to convert to molecules. On the top, I have moles. So on the bottom here, I have to have moles. According to the conversion, 1 mole of a substance is equal to Avogadro's number of molecules, 6.022 times 10 to the 23rd. So to solve this problem, let's cross out our like units. Grams disappear, moles disappear. The only unit left is molecules. I highly recommend canceling out your units like I've been showing you in all of these problems, because you know that you have your conversion correct if the only units that aren't canceled out are the ones the problem is asking for. And this is going to become very important when we get to stoichiometry next week, because stoichiometry is essentially an extension of this. So we need to multiply 14 by Avogadro's number, 6.022 times 10 to the 23rd, and then we need to divide. What we're going to do is we're going to skip this problem because I made a typo here. All right, so let's go right to our learning check, and I apologize for that. All right, again, I apologize for that. I can't edit this and exit out of the narration at the same time. Here are your two learning check questions. First question, how many molecules are there in 5.2 grams of ammonium chloride? Second question, how many grams are there in 10.2 times 10 to the 23rd molecules of nitrous oxide, or from our conventional naming, dinitrogen monoxide? So please go ahead and take approximately 8 minutes to complete these two problems, and then we'll discuss the answers. Okay, please take another 2 minutes if you're still working. Okay, please finish up with these two problems, and then we're going to go over them. Let's discuss the first learning check question. How many molecules are there in 5.2 grams of ammonium chloride? Step 1, calculate the molar mass. I have one nitrogen with a mass of 14 grams and 4 hydrogens that each have a mass of 1 gram. Again, notice there is a typo here. So that should say 4 grams. And then 1 chlorine that has a mass of 34.45 grams. So when we add these together, we should get a molar mass of 51.45 grams per mole. Now, we're going to convert. We start with 5.2 grams. Starting with grams on the top, we have to have grams on the bottom. So if there's 51.45 grams in 1 mole, now we can convert from moles to, to molecules. Okay, so the plan here, is reversed. So let me fix that. Okay, I apologize for the typos. All right, so grams to moles to molecules. It's very hard to draw with your laptop trackpad. How many grams are in 10.2 times 10 to the 23rd molecules of dinitrogen monoxide? Molar mass, 2 nitrogens at 14 gives us 28 grams. 1 oxygen at 16 gives us 16 grams for a molar mass of 44.0 grams per mole. Now, we're going to convert from molecules to our central value of moles and then use the molar mass to get to grams. So, on top, we have 10.2 times 10 to the 23rd molecules. Since I have molecules on top, I need molecules on the bottom as well. So, Avogadro's number of molecules is equal to 1 mole of dinitrogen monoxide. Then, we know that there's 1 mole of dinitrogen monoxide in 44.0 grams of dinitrogen monoxide. Canceling out like units, we're going to multiply the 10.2 times 10 to the 23rd times 44 and divide by 6.022 times 10 to the 23, and this is going to give us a value of 74 0.53 grams. Now, as you see on the board, you have two worksheets that are due tomorrow for homework. The molar conversion worksheet 2 and molar conversion worksheet here. Based on the timing of my slideshow, I'm going to factor in that there might have been a couple minutes to get logged in on the computer. You have ample time to get started on these worksheets in class today. Please utilize your time in class to start working on molar conversion worksheets 2 and 3, as what you finish in class will be due for homework tomorrow. So you'll get a lot of practice doing these, and then I'm going to post the answer keys to these over the weekend. Tomorrow we're going to be talking about percent composition, which uses a lot of the information that we discussed today, and that'll be a recorded broadcast as well. All right, so I hope you guys have a wonderful day, and I'll be broadcasting again to you tomorrow.